two lunar missions launching at the same time, racing to the moon. No, sorry, not racing. One's going to get there a lot faster than the other one's going to get there. These missions kicking off 2025 will set the tone for the rest of the year when it comes to these small commercial lunar missions, including any future CLPS missions. That's NASA Commercial Lunar Payload Service missions, which is what the Firefly mission is. Whether they succeed or whether they fail, it will help us determine how this program is going, how the CLPS program is going, and whether or not it is a success or failure in the eyes of the new administration that will be coming in very shortly. Flying on a SpaceX Falcon 9 at the same time, launching from Florida, we have two lunar missions that were not necessarily planned to launch together. In fact, they weren't even confirmed to launch together until about a month before the launch. And so it's pure coincidence that these two missions are going to the same place, taking different routes. I have to admit that I thought Firefly was a goner back in 2016. Firefly Space Systems did actually go through a bankruptcy. They dissolved, they got acquired, and they were resurrected as Firefly Aerospace. And ever since then, they seem to be going fairly strong. Their launch business has a mixed record. We haven't seen them launch in quite some time. This is the first activity we're seeing from Firefly in a while. The first time they're trying to launch a lander to the surface of the moon. We know that they're already behind schedule, which is not a surprise because when it comes to these kinds of missions, everything is behind schedule. The CLPS award was given to Firefly back in December of 2021, planned for a 2023 mission, so it's about 2 years late. The contract was $93.3 million. $93.3 million, so less than $100 million. That's actually really cheap for this kind of mission. And that's the idea with CLPS. The idea was that these were going to be low-cost missions that NASA was going to fund to help the commercial space industry mature when it comes to having transportation and creating a supply chain to and from the moon, non-crewed, uncrewed flights. And so these are low-cost missions that NASA knew would be risky. NASA knew that they would not all succeed. NASA estimated about a 50% success and failure rate. And so far, we have not had that. We've had less than a 50% success rate with the two launches that launched last year. So we have now this third CLPS launch. How will it fare? Will it be another failure, a partial success, or a complete success? I'm on record saying that sometime this year, we will have the first CLPS complete successful mission. Will it be Firefly? I don't know. So Blue Ghost is the first mission. It is called Ghosts in the Sky is what they're calling this mission. I love the creative names in this industry. It's delivering 10 NASA payloads to the surface of the moon. I will link below an article where you can, or actually it's a Firefly website where you can see what those payloads are. I want to specifically point out two that I have a personal interest in. One of them is the stereo camera for lunar plume surface studies. I studied lunar plume surfaces for my graduate program. I mean, I didn't actually study them on the moon. We simulated them, but that's the intent, is to figure out what the dust dynamics are when you land something on the surface of a dusty planet. And so this will give us actual photographic evidence. These cameras will actually record the landing, the dust that goes up and the plume that is created when we land a small lander on the surface of the moon, so that we can better prepare when we land larger landers on the surface of the moon. In this same related vein, we've got the electrodynamic dust shield. And I remember in grad school, it must have been like 15 years ago now, I don't really know, in Kennedy Space Center, there was a PI, Carlos Calle. He's retired now, but he demonstrated this and I was just in awe. I think this is fantastic technology. I love that we're finally flying this technology to see how it reacts in real life, in situ. Blue Ghost is going to launch tonight, hopefully. It will orbit Earth for about 25 days. It will head over to the moon, take about 4 days, and then it will attempt a lunar landing, a soft, controlled lunar landing. And that'll be about 45 days from launch. And it will have about 14 days of surface operations. Why 14 days? Well, it's not designed to survive lunar night. The lunar day is about 14 days and the lunar night is 14 days. And that lunar night is very dark and very, very cold. And so there are very few missions that are actually designed to withstand past that 14-day mark into the cold of the lunar night. Also on that Falcon 9 is the Ispace Hakuto-R Mission 2, Resilience. And I need to go back. This is not a CLPS mission. However, it does have its origins in the Google Lunar X Prize. And so in 2010, there was a spin-off company that became Ispace. And so ever since 2010, Ispace has been trying to get to soft landing on the surface of the moon. If you remember Mission 1, it attempted a landing in April 2003 and it didn't quite make it. It crashed. What happened was that they changed the landing site just a few months prior, and they didn't do enough modeling testing with this new landing site. The landing software misunderstood where it was. It thought it was at like 0 altitude. It thought it was at the surface, when in fact it was hovering at about 5 kilometers. And it ran out of propellant and then it crashed. According to Ispace, everything else went right with that first mission. It just didn't understand where it was in space as it was trying to land on the surface of the moon. And so Ispace has now had some time to fix that and has mission 2. Resilience is going to attempt a landing in Mare Frigoris, and hopefully it will succeed this time. It has its own Ispace designed rover. It's a micro rover. It's called Tenacious. I love these names. There's Ispace Europe in Luxembourg. There's Ispace Japan. There's Ispace United States. And so Ispace Luxembourg is the one who designed the rover. Ispace Japan is the one who is launching this mission, or I should say running this mission. Aside from that rover, it has a few other payloads on it. The one I want to talk about is actually related to NASA. So go back 4 years and you might remember that NASA awarded some contracts to some companies to collect lunar regolith. Not to bring it back, not a sample return, but simply just to collect it, to dig it up as a beginning, almost a president's setting for in situ research utilization of the lunar resources. And so NASA awarded contracts to Lunar Outpost for $1, which just cracks me up. So 10% of the award was awarded to these companies initially. And so of that $1, Lunar Outpost actually got a 10-cent check. I love it. They also awarded contracts to Ispace Japan and Ispace Europe, $5,000 each. Were those awards, and to Masten Space Systems, which no longer exists. They're now under Astrobotic, but I don't think that award translated over to Astrobotic, but I might be wrong. Ispace is actually going to attempt to collect the regolith for that award during this mission. So they're not going straight there. They're not even doing that 45-day travel like Blue Ghost is. So what Ispace is going to do with its lander is take a slow approach, about 4 or 5 months. Once they get there, they're going to do not just collection of regolith, but they also want to test an electrolyzer. So breaking up that water component of the regolith into oxygen and hydrogen. Also, interestingly, they partnered with another organization to try to do food production with microalgae on the surface of the moon, which they're saying is the first time that's ever been attempted. Very cool missions. What does this mean for the greater picture of lunar exploration? None of these are sending people on board, right? But this is just the beginning. We had last year a series of lunar missions. There was the SLIM mission from Japan that did have a really great precision landing, but then tipped over. There was the Intuitive Machines mission that did also have a not as soft landing and tipped over. There was the Astrobotic mission, which didn't quite make it. Really only China has had really good success with their Chang'e missions. What we want, what NASA wants, what European Space Agency wants, is to establish this supply chain, this means of bringing equipment, bringing scientific instrumentation, bringing resources to the surface of the moon and hopefully back again. And so people are waiting for these large lunar landers like Starship HLS and Blue Moon, but we don't always need to bring a giant lander. Sometimes it works best to bring smaller landers, especially if we learn that the regolith is very much disturbed with the larger landers and less disturbed with the smaller ones. Also, we want the diversity of those landers. We want the diversity of players. It's not good to have just one, as we have learned in the past. You want a diversity so that you have that dissimilar redundancy and so you have multiple hands who are working towards a greater mission. And as you can see, both of those missions are working towards similar goals of understanding the lunar regolith, understanding how we use the lunar regolith, and understanding some other properties. There's X-ray spectroscopy. There's other scientific data that we need to collect in order to better understand the surface of the moon and the lunar environment so that we can hopefully set up a lunar base there and live there long term. That's not the current plan of NASA, but that is hopefully the longer term plan for the space community, is to set up a permanently inhabited lunar base and stay there, understand how to live and work on another planetary body. Get ready, because the launch is happening. It's almost time. Come watch it with me.
There it goes. to the moon.